Welcome, Mr. Anilkumar, and we are about to begin the next session of the day. We're going to discuss on the advanced metering technology. And ladies and gentlemen, let me introduce Mr. Anilkumar Kadam, Senior General Manager, EcoStruxure Solution Architect, Schneider Electric. I would request Mr. Anil Kadam to please take over. Thank you.
All right, thank you. Thanks very much for this opportunity. Quickly, just a small word about what Schneider Electric is. Schneider Electric is a multinational company headquartered from France, but now equally available across the world. In India, we are 32,000 employees, and we are very much focused in the smart grid domain. We are in the core of energy management. Enabling energy management for smart utilities. Now, a lot has been told by Mr. Ganesh in the previous session. Smart metering is just not the smart meters connected to the consumers. It is about a holistic system connecting different entities within the electricity business process. So what you see, the smart meters itself at the consumer is just the tip of the iceberg. There's a lot below the iceberg which needs to be unearthed. So the potential benefits through leveraging the information from AMI, advanced metering infrastructure, is manifold. I will go by a step by step what do you mean by smart metering and what do you mean by AMI in the subsequent slide. But just to give you a heads up, it promises to reduce commercial loss, which is a big problem of our country. AT&C loss, accuracy on billing and other services to customer will be improved. Improved asset management. I'll explain you what I mean by asset management. Even Mr. Ganesh referred it. Optimize energy and network usage. We have limited network. We have growing loads and growing consumption. So it helps you optimize the energy and the network usage. It helps you to reduce the outage number of durations and the duration. Okay, it helps you accommodate renewable and creates microgrid communities, helps you improve network operations, helps increase efficiency. We'll see all that going further. And very important, it helps you manage the peak, by intervening with demand side. So let's see how it is. So advanced metering infrastructure framework for modern grids principle. Now, so an AMI should kind of be very futuristic in the vision. When in India, when AMI discussion started, it was more of AMR in RAPDRP, where a lot of DT meters were connected for a single direction communication to the control center. So it was mostly limited to one direction data. And it was mostly limited to energy audit and billing purposes or energy reconciliation purposes. But once the communication technology started maturing towards bidirection, people started realizing that there is a good amount of use cases which can come up by leveraging this bidirectional data flow. The first and foremost important criteria what an AMI brought in was, can I accurately bill the customer? Can I connect and disconnect? That means, can I do load control, full load control or internal load control? Can I transact with the customer in terms of price signals? Can I make the customer more aware of the problems what I'm going through as an utility? And very importantly, there were a lot of complaints coming from the customer which I was not able to arrest in terms of voltage problem, in terms of outage problem. So can I kind of proactively analyze what kind of quality of supply I'm giving to the customer? So that's AMI. Now, how does it integrate with the future vision is another important aspect. Now, an AMI to be successful as a program should motivate and include the customers at the core. That's a very important aspect. So how do you enable the regulatory framework? It's a very important framework. That means just take price, time of use pricing, or incentives to the customer for participating in demand response. It should be compelling for them to participate. Second is, it should accommodate all kinds of generation and storage options. With the advent of smart grid, what more and more is coming is renewable, a rooftop solar or storage, or a simple inverter in the rooftop solar to be integrated to the grid, so on and so forth. So how does an AMI accommodate renewable generation in the strategy of distribution company? Enable markets. Now the market should be very futuristic. That means with the privatization in the infliction, there could be multiple content owners on electrical wire. So how do you reconcile different content on the same carriage? Should be also the AMI function. So the design should take care of that as well. It should provide power quality for 21st century needs. Resist attack, as Mr. Ganesh said, cyber secured. It should be very important to help self-heal. For every intervention, we had to get our people to the field, get it rectified. Can the network self-heal by using the data coming from the AMI? And then help you for optimizing the assets and efficiency. So that's all about motivation for the future AMI. Now, what is AMI? AMI is seen very standalone with 3 layers always: the meter, the communication, and the software systems in the distribution control center or the distribution entity. But AMI is much more. AMI should primarily, prima facie, the component of AMI is whenever somebody purchases AMI, it's smart meters, communication network, the MDAS communication network, and the MDM, HES, and MDM. But look at the complex connection what an AMI system should help achieve. It should be able to connect to a load at the meter point. It should be able to connect to an in-home display or a home area network, or even a smart enterprise building automation system, so that we are able to get to a deeper or a finer load control. That's one communication of a smart meter downstream. At the same time, the AMI network should be able to get to other operational systems of the utility, so that the data can be leveraged much better in the other domains. So we will see that going further. Okay, so you have smart meters, you have wide area communication, home networks, meter data management, and operational gateways. So note the point of operational gateways. How deeper the AMI data gets into the operational gateways of distribution company really determines the ROI of AMI, so AMI network itself. So everybody knows about smart meters. I will not really delve deeper into smart meters, but it is a meter which is to be futuristic, which should completely handshake with the AMI use cases. So in that way, the meter selected should be very, very futuristic, because meters stay for long. It should support time of use pricing. It should have a very open communication protocol. It should have load controlling possibility. It should have power quality monitoring, and so on and so forth. So the message here is the meter, what has been installed, should be very futuristic, so that it can slowly lend itself for higher possibility of use cases. Example, it should be having a protocol to communicate for the home area network, or the building automation system. And on the upper side, it should be on DLMS COSM, and so on and so forth. I will not spend more time. Much has been spoken on communication infrastructure by Mr. Ganesh. But here, how can an utility be efficient in using the existing communication infrastructure? At the same time, the communication infrastructure should take advantage of the upcoming enhancement. For example, there was a mention about NB-IoT on the same GPRS network, or the same 3G or a 4G network has to be an important enabler. So way back we started with Powerline, and then we said BPL, and then somebody said, from the MDAS or the data concentrator, it has to be a copper link, and so on and so forth. Today we are in the era of point-to-point communication, and in the country there is good amount of deployment on point-to-point on GPRS using 3G, above GPRS on 3G, and on probably NB-IoT and LoRa kind of technologies will take over going further. So it's very important to choose a futuristic communication technology, and depending upon the use cases what an utility is wanting to hold in the future, the communication technology has to be chosen today, the best one today. Okay, the home area network, the maximum usage of a demand side management is if an AMI is able to penetrate deep inside the demand side. Okay, in the US, there are programs where smart meter is able to talk to a smart thermostat inside, because heating is one of the major loads of in such countries. So it is able to manage the set points of a thermostat automatically for a participation of demand response. And of course, there is a regulatory framework to incentivize the consumer having participated in the demand response. At the same time, there are all our other loads inside. Example, if there is a home area network, there is a washing machine, there is a heater there, so you can set reference time within which it can operate, and we can be more and more efficient. So automatically the bill reduces of the consumer, and he is very much motivated to get inside the program of AMI. Now AMI technologies are predominantly, as I told you, the MDMS, the metadata management, which is the core software, and which is going to be consolidating all the data coming from millions of meters there and making it available to the other systems in the format what is needed and in the protocol what is needed, which is enterprise service bus today or publish subscribe. But it's very, very important that MDMS platform is very futuristic, and it paves itself for a big data kind of an analysis, so that you will be able to do much more going further, or not restricted. The platform is restricted, the whole AMI is restricted. So it's very important to be futuristic in MDM. I will show you quickly how an MDMS looks like. Now, very important is, after the data comes to MDM, from the smart meter through the communication channel to the HES, head-end system, and then the metadata management, the data has to be shared to different operational domains. So I call it as operational gateways. One of the operational domain, the data has to be seamlessly integrated, is advanced distribution operations, which is like a real-time application. So what are the different advantages of integrating AMI data into advanced distribution operations, like integrating with ADMS, advanced distribution management system, integrating with SCADA? Very important is in a distribution management system with advanced sensors, we'll be able to know last load level data, so that I will be able to do proper load forecasting. Otherwise, it will be more of predictions. I will be able to do proper load forecasting, so much so that my purchase patterns will increase. So efficiency of purchase in the distribution domain increases. Next is, I need not wait for a phone call from a consumer to say that there is an outage. I automatically know that there is an outage because the meter told me there is an outage. Otherwise, I had to wait for a phone call or comprehend with the GIS to say which feeder is a problem. Similarly, there is innumerable DERs coming into picture. So how do I know which DER on a consumer of a last level, commercial, industrial, residential, will produce power, and will be able to supply to the grid whenever it is needed. So it's important for DER operations. The AMI data is very, very crucial, and it's a gold mine. And then distribution automation, volt-var optimization. Most often for volt and var optimization, we are doing it at the primary. Distribution stations. This helps you to do something lower level, so that you are more granular. Okay, and of course, enable microgrid operations for microgrid community. That means I will be able to reconcile the energy, and I will be able to sell the energy as a consumer to another preferred customer of choice through an app which is actually connected seamlessly to the AMI. So therefore, you are trying to enable microgrid communities. Another important aspect of microgrid communities is to establish reconciliation of green certificates to different consumers. So that's very important to seamlessly integrate AMI data into advanced distribution operations. Next, advanced transmission operations. So AMI data is also a gold mine for advanced transmission operations, because at the end of the day, you have a complete visibility at the consumer side to the distribution company, and that in turn can be used for managing the transmission operations. Okay, which is also more of electricity markets. That means you have a better visibility. A distribution company can do real-time purchases most efficiently because you have AMI data. And last but not the least, which is very important from operational gateway perspective, is advanced asset management. That means you have data which can enable condition-based maintenance, which can slowly graduate to the level of predictive analytics. You will be able to create a digital twin with so much of granular data, because we are getting into the domain of real-time data archival to the analytics part of it. And then you can apply all the future technologies to get a very seamless asset management perspective. So that's about operational gateway. I wanted to take a little bit of proclaimed investment benefits what USA, a major economy, has gained using AMI. We are also in India. We are also deploying AMI, and we have started deploying it. But there is a mass rollout of AMI in US, and there is a there is the smart grid investment grant program, and you see these are the benefits. It helps reduce cost for metering and billing, which is quite obvious. That means you don't have manual billing, and it improves the accuracy. More customer control over electricity consumption cost and bill. That means we are reflecting him, granularly, how is he using the electricity, so that he changes passively, and also we help him change actively the energy efficiency. Then lower utility capital expenditure and customer bill saving. So that's a very important aspect, because you are able to reduce the peak, and you are able to do more with the existing infrastructure, the utility, because your demand response, you are actually handshaking. Lower outage cost and fewer inconvenience of the customer. And today, we in the country, we have power quality related penalties, which is going to be coming to the utilities. So we can reduce the outages, we can reduce the discomfort of the customer. At the same time, the utilities can save on the quality of service cost. So that's the acclaimed benefits. So very clearly, AMI data is fundamental to any utility, and that utility has to realize, and that uses it enables a lot of use cases and more effective usage of distribution domain, transmission domain, and asset management domain. So that's about the deployment part. That's about the AMI part. I just wanted to show you the architecture and how the seamless connectivity happens. You see, you have the field devices here. The meters are here, the smart meters are here. You have feeder automation here. You have substation automation. You have storage, DGs, and flexible loads, and smart devices in LV. So the biggest gold mine for a distribution company is to automate the low voltage part. From last 10 years or 15 years, we have seen a lot of technology intervention on the primary distribution part, which is prima facie a medium voltage level, be it 33 kV and 11 kV. So enough intervention has been made. But with AMI, it enables LV automation, which is 3 times, 4 times as larger as a medium voltage network. With that data coming in, you have a main HES, which is picking that data and pushing it to different operations domain in the architecture on enterprise service bus, plus different IT levels for business process application, maybe customer care, maybe billing, maybe trading, and so on and so forth. And then the huge amount of data is available for your further analysis in the big data format in the form of analytics. So this is a futuristic architecture for AMI. Okay. So that's the architecture part. I wouldn't go. Scalability. The platform what is selected, be it the HES or be it the MDM, it should be a platform which is scalable for future, because today the consumer base might be 1 million. In no time, because of industrialization and people moving into the cities, we see good amount of new connections coming in. So how does this platform scale itself is another very important aspect to be seen. Okay. So I wanted to just leave you with a little bit of dashboards on what do we mean by AMI MDM. Ultimately, you see an MDM dashboard looks like this. It is able to really say how many meters were read, how many meters were not read, what was the reason, and helps you manage that particular aspect of the number of meter reads. And then very important is, after data comes, the platform should have robust validation, estimation, and editing technologies, so that you can fill the data or you can correct the data what is wrong, so that you are dependent on multiple business process for it. So a platform should be very, very strong on the validation rules and estimation rules. It should have a plethora of validation rules, zero consumption, negative value checking, and so on and so forth. So that's where the MDM and the HES makes a very important part of the AMI. I'm just not going to go into the details of it. You can see the validation engine is auto-corrected the data and estimated the data which were missing because of either a communication problem or because of the meter was not able to communicate, and so on and so forth. And there is a correlation with that particular data with respect to the temperature and with respect to the other parameters, reading graphs, events on timelines. You will be able to interact. Why did the voltage swell happen, and what was the temperature at that point in time, and what were the different parameters? You can still do it. The end-to-end meter to cash support, time of use, hourly rate, seasons, and so on and so forth. Billing quantities should be there. So AMI should be should be visualized, should enable you a GIS visualization, so that you will be able to track the end meter from the complete plethora of complex network. Okay, and trace meter down to a transformer. So transformer loading analysis. and so on and so forth. So I'll just leave you here, and I'm open for any questions. While there are a lot of slides which I want to cover, but plausibility of time, I'm just stopping here. Okay, Schneider Electric has done many AMIs and large AMI systems. We have done in Iberdrola, Fortum, Vattenfall, SEM, and it is we have done projects more than 3 million, or I mean up to even we have connected meters up to even 3 crores on our platform. So I let here and let me get on the questions so that we can utilize the last 10 minutes for questions.
Well, thank you so much. Well, now I request the audience to please raise your question. Any question? Any question from the audience?
How do I see the questions? Do I get it on the chat, or you will read it for me?
You can check on your chat list.
Okay, there is a question on what is the best communication option for smart meter. It depends upon utility to utility and the location, but today I would recommend to use point-to-point communication and leverage the existing communication infrastructure led by the large communication companies. I would say NB-IoT is the future for smart meters. If you go with your own captive network or having your own PLC kind of a network, it is going to cost a lot of capex for the utility. So it is important to acquire benefits as early as possible so that people start believing in smart meter technology, people start believing in AMI, and business starts getting leverage of AMI. So it's important to use the existing infrastructure, and NB-IoT today in the country is fast growing. It is going to be the technology for smart meter going further. It's point-to-point communication. Okay. Any other questions, Edmund?
Yes, there is one more question.
Can you read that for me?
Yeah, we're just sending you.
Yeah.
It's sent already.
It's probably the same question which is repeated in a different format. It says, what is the best communication technology? I just answered it.
It says combination.
Okay, what is the best combination of communication technology? A combination is completely dependent upon your regional requirement and the presence of communication infrastructure service provider. Example, if you are in a city kind of an area or urban kind of an area, you have 3G, you have 4G, which is abundantly available today, and NB-IoT is also getting rolled out in many places. But if you are getting into rural areas, you have still Gprs and 2G working well, and I have seen in rural areas 3G is also working very well there. If there are areas where absolutely there is no connectivity and it is too poor connectivity, I would rather propose localized PLC there, either G3 or Prime. But otherwise, you would find all wireless technologies and communications available everywhere. Okay, the cost of NB-IoT is drastically reducing. I accept with you on when the number of points was very less on the monthly rental, but the cost going further with NB-IoT will be very substantially low. And at the same time you should see how are you going to, because over a period of time, if you have this infrastructure, you should see over a period of time the technology changes, and you should continue taking advantage of the new technologies. If you install your own RF network, you may probably have to use the same technology for a longer time because you already invested. But with the advancement in communication technologies, it's more wiser to go with service providers who are able to get you to the last point. You might have seen in the last couple of big projects, the cost of communication is drastically reduced. I mean, it is reduced of orders unbelievably.
Well, I think there's one last question. What is the major benefit in using NB-IoT over 2G or Gprs network?
Mr. Kelly, please join.
Cost.
Link.
It's going to be cost majorly.
Okay, fine. So anything else which you would like to add on at the end?
No, sir.
I just wanted to make another very important point here. While meters are going to stay for long, the meters are supposed to be very futuristic, as I said previously. What's happening today is in the bulk procurement of the meters, there is continuous pressure on the cost and the price coming on the meter. So since meter is the gateway for the demand side, I would recommend that there has to be a quality come cost basis evaluation for meters, so that the hardware what has been chosen for the meter and the is quite robust and futuristic. It should not be pressed under the procurement of L1 procurement. That's one point. Second point is the platform which you are going to purchase, be it the head-end software, be it the communication infrastructure, the head-end software and MDM is to live for long. So I would recommend you have to platformize it. There has to be best of the best platform which has to be on your system, because this is like the artery of your system, supplying the essential data for your more optimizations to other operational gateways. So evaluation of this platform has to be on quality come cost basis, not on L1. This is a very humble submission for me. And the technology service provider or a solution provider has to be a partner for a long time. And the smart grid technologies, which is prima facie, has to be seen as a technology or an intellectual solution over the electrical commodity tender norms. It is not a transformer, not a product, nor a breaker which has to be going on an L1 with a technical specification. It is a partnership. And I would recommend it has to be dealt intellectually, and it has to have different kinds of terms and conditions for a smart grid supplier. That is what I want to leave you with. Thank you.
Mr. Kadam, just one more question.
Yeah.
The question is, what about NAN and WAN combination? Do you think it is the future, or can you suggest any other?
Say that again. I did not hear you clearly.
What about NAN and WAN combination? Do you think is the future, or you suggest any other?
See, neighborhood area network is very much needed. Because today we have still not matured to that level. The ultimate is creating microgrid communities. When I say microgrid communities, the communities should be able to generate their electricity, consume their electricity, and pump the remaining one into the grid. And the consumer should have the capability to sell it to somebody whom he gets better money, or to somebody of his choice. So neighborhood area network and WAN is definitely going to be a need going further with evolving microgrid communities. At the same time, we are very happy to see that the regulation is started progressing in India to have ancillary services in smart grid, to better leverage the ancillary services in the smart grid, including the storage, and the EV charging. NAN and WAN cannot be avoided. So neighborhood area network is a must. Because I charge my car somewhere in the parking, I discharge it in my office space, and when I charge the car, the rate of the energy was say 5 rupees per unit. When I discharge it, it was in peak, it is 6 rupees or 7 rupees per unit, and I'm supposed to be getting back that 2 rupees, for having accepted to discharge in the peak time. So how do I reconcile that? That is through a van, right? So NAN and WAN is definitely an important concept, and it has to grow further. I am also seeing NB-IoT will fetch itself to create that NAN and WAN, unless the technology doesn't answer. But I think NB-IoT is going to take up all of that. It is going to be connected to electric vehicle. It is going to be connected to storage, bulk storage outside, or a local storage inside the house, or a commercial building. It's very much a need. It's very much a need. No, I said entire AMI. I did not say communication should not be QCBS. Every component of AMI should be QCBS, and it's a long-term partnership. It is just not a product which I sell and for a required GTP, guaranteed technical particulars, and a type test. No, I'm not biased on communication. There has to be due value given to all intellectual components, and communication is the artery of the system. I don't say it should not be. It should be on QCBS. But what I said was the cost of communication is drastically coming down, as we have witnessed over a period of time. You have seen what the cost of communication in the first tender of AMR. Then we saw what was the cost of communication in cost of communication in RAPDRP SCADA DMS. Then we saw what is the cost of communication in ESL kind of large, 5 million kind of opportunity. Now we are going to see a further reduction. So it's the scale which is bringing in the cost reduction. I'm not talking that it is just as it is, and it is equally important. NB-IoT is implemented in a couple of parts of the world. We ourselves have done it in Vattenfall. We ourselves have done it in Finland, and there is some tests going on in Spain. We have a huge install base, connectivity of HES and MDM in Spain. There are places where there is a huge rollout of NB-IoT going on.
I think we are done with all the questions, and you have answered wonderfully. Thank you so much, sir. Have a good time. Thank you.